This is an interesting piecewise function because it uses the square root function in kind of an interesting way. So we always do piecewise functions. The top part is on the left, and as we read it going down, we move more towards the right. So I'm going to do the left part in green, and the one that's further right, or the second piece, in black. So it says we want the function absolute value of x where x is not equal to 3. Well, that means I want x, here if I go 0, 1, 2, 3, 4, 5, negative 1, 2, 3, 4, 5. The only place I don't want it is at x equals 3. Every other x value I want to have in this first piece of the function. So the absolute value of x, I know what that function looks like. It starts here at 0, and it's kind of the V-shaped one. So I go like that, and then I go like that. That is my absolute value function. But I don't want it where x equals 3. So where x equals 3 is kind of right in there. At x equals 3, I have an open circle. So an open circle at the point 3, 3, because that would be the absolute value of 3. I have an open circle there. And it says, well, fortunately on this particular one, I guess fortunately, it doesn't really matter whether it happens or not, but it says it does define me a value where x is equal to 3. And that value is the square root of x. So if I did a little t-square, I have the square root of x, and when I enter an x, I only have one value I really need to do, which is 3. Well, I don't know what the square root of 3 is. I'll get my calculator and get a little estimate here. So the square root of 3 is, well, second square root, 3, enter, 1.73. So, you know, let's estimate a little bit. At 3, 1.73, and that is just a single dot right there. So that is the point right there, 3, 1.73, or 3. Really, it's 3 square root of 3 is the exact point. So for my domain of this function, as I was showing you right here, well, I didn't have a value in the first part for x equals 3, but I do have a value in the second part for x equals 3. So that actually fills in that open dot. So my domain, let's do this properly here. My domain for this problem is negative infinity to positive infinity. All real numbers are going to be included because the absolute value function is going to go out here, all the x values to negative infinity, and it's going to go out here, all the x values to positive infinity. It skipped this little spot there, but on the x scale right here, I filled it in with that dot. Range, well, the range on this is kind of interesting, actually, now that I think about it. My lowest y value is 0. I don't have any y values down here. My lowest y value is 0. So that is going to be the bottom of my range, and it's going to be included because it's included in the absolute value function. Now, I'm going up here, and I see I have a hole right there. So I might think that 3 is not included. Even though I have the x value here, the y value is in 3, the y value is 1.73, or the square root of 3. So I might think that I'm skipping 3, but don't forget you have this other wing of the absolute value function that's going up, and that does include the y value of 3. So the range on this particular function would be 0 to infinity. I'm not skipping any y values. All the way from 0 up to infinity, every single y value is covered in this function.